Hello everybody, my name is Trontor Wang, and welcome to Kanji Katana, a 3D open-world game for learning Japanese. I'm under Dr. Yilmaz in the SysLab. So, for background, learning languages requires memorizing thousands of words. And looking at Japanese specifically, there's 3 alphabets, hiragana, katakana, and kanji, with kanji having over 40,000 characters. And when we learn Japanese, you need at least 3,000 to 5,000 words for basic fluency, 10,000 for pretty high level fluency, and 30,000 for native level of fluency. And this number of words is just absurd and impossible for most people, which is why they don't even try to learn languages. But there is a solution to make this process as easy as possible. It is called daily spaced repetition learning. And how this will work is, let's look at the graph on the right. We got to first understand what the forgetting curve is. So let me give you an example. Let's say you're trying to remember the information, the sky is blue, and this is the first time you've ever heard this for whatever reason. The first time you hear this word, this information, the sky is blue, you'll forget it very quickly. If you don't review it and just don't think about it, maybe just a day or two later, you'll completely have forgotten it. And if you look at this graph, it says 3 days later, you'll have forgotten basically 40% of it. But if we review it pretty early on, you remember it again, you'll remember it for longer this time. So instead of forgetting it in 1 day, maybe you'll forget it in 2 days. If you review it again in 2 days, you'll remember it for 4 days or 5 days. And basically, as you continue to relearn this information, the sky is blue, you remember it for longer and longer and longer periods each time. And eventually, let's say you can just remember it, and then you'll remember it for a year. And if you review it one time in the next year, you remember it for the rest of your life. And what Anki does is it's an application which automatically builds these flashcards for you. And as long as you do it every single day, it will show you the correct flashcards that you will need to be reviewed for that day in order to optimize your remembering. And also at the same time, you are reviewing that card for the least number of times possible for the maximum results. So it allows you to memorize thousands of these words without even trying, because it will automatically show it to you when it needs to show it to you without you having to do anything besides just log on every single day. But the problem with this app, Anki, for learning Japanese, for example, is it's really boring. I myself, for the past 3.5 years, have used it to learn over 4,000 words. And I can tell you firsthand, it is pretty boring, although it is very effective. So let's look at other solutions for learning Japanese. One is you can use these apps called Lingodeer and Duolingo, which you've all heard of. But the problem is, it's really boring, first of all. It still feels like you're not playing a game. It feels like you're doing work. And there's no spaced repetition algorithm, which means it's up to the player or the user to actually go back to previous lessons to review what they've forgotten, which makes it kind of hard. And there's also other solutions like these games which try to make it more fun, like Kanji Katana, or not Kanji Katana, that's my game, Learn Japanese to Survive series. The problem with these games is it sacrifices the actual efficiency of, for example, a spaced repetition algorithm. It does not have it. It focuses too much on the gameplay aspect and not enough on the Japanese learning aspect, sacrificing the actual efficiency of learning. So here is my solution. Kanji Katana. So, what is it? Kanji Katana is a 3D open-world daily level game, and it can be used to memorize Japanese alphabets, characters, words, and some grammar. And the goal is to make memorizing words easy. And here is a simulation of what I thought that might look like. For example, you have a player here and you have an enemy in the distance, and the enemy shoots these blocks at you. For example, let's look at the green block, ka. Let's say you see this word ka. Then your job would be to physically write on your screen ka. You would draw it on your screen. And if you draw it correctly, you'll successfully break the block, and then you will do damage to the enemy. So, why is Kanji Katana better than Duolingo or these other games? It's because it combines both the fun aspect of these games with the efficiency of the spaced repetition algorithm in Anki. So it takes the best of both worlds, the algorithm and the gameplay, and combines them to make a fun and efficient game. Additionally, it's going to look very, very cool, with animations, particle effects, appealing colors, maybe even multiplayer, and cool camera movement. So for some background, I'm going to be using the Unity game engine to create my game. And the Unity game engine is a cross-platform game engine with built-in lighting, rendering, and it allows you to easily code and connect your code to your game. It also has thousands of pre-made packages, and there's tons of famous games like Fall Guys, Among Us, Pokemon Go that were made with Unity. Additionally, I will be posting it on the Steam web store, which is a pretty big web store where you can download games on the PC, and not just on the PC, but mine will be. And for the impact, I hope that this tool will help basically be a permanent tool that all Japanese learners can use to start learning Japanese. And it's even a great option for people who are not currently learning languages or not interested in it. Hopefully it can get them interested because of how easy it is. I can hopefully expand the entire language learning community and beyond. So let's first look at the method of our enemy, because the enemy is what actually teaches the character, the player. They are the ones who are shooting the blocks which the character must respond to by counterattacking it to actually learn these new words. And all the enemy does is it wanders around this 3D world. And if it's really far away from the character, it'll just wander around. If it gets close enough to the character, it'll start following them. If it gets really close to the character, the player, I mean, it will start attacking the player with these blocks. And each of these blocks will correspond to these different characters that the player must draw in order to actually break the block. And then let's look at the method for the character. So for the character, I'm actually using a bone hierarchy. So the character basically has a skeleton, and the skeleton can be animated with pre-made animations to make it a lot easier. I'm actually using this character model from Mixamo.com, which is a really nice site, and I'm also using the animations from Mixamo, and I'm animating it with Unity's built-in animation like node tree. And here, the player has all the animations for walking, running, jumping, sprinting, landing, and it uses these parameters to check if the player is walking or falling or grounded or jumping, and based on that, it plays the correct animation that it should be doing at that time. And for terrain, which makes the world look cool, obviously, I'm using Unity's built-in terrain tool, and here's actually an image from, all these images are actually from my game, and you can see I can kind of draw in the trees, I can draw in the terrain, and it's very optimized for these games, and it runs very well. So as we can see, all of these things combined together, we can see the player is able to walk around this world, and they're able to sprint, and they're able to jump, and then there's an animation when they land, and yeah. Moving on. So, the word manager. So how does the player actually, or how does the enemy actually know what words to give the player, and which words the player must review for that day? Well, it has a JSON file stored on the player's computer which keeps track of all the words that they need to be learning in the future and today and need to be seen today. And the words that they see today will be sent to the enemy generator script, which will basically split and allocate the words that are due for today into different enemies. Also, the player, in case they ever forget what, for example, let's say they're given the word ka, if they ever forget how to write ka, they can turn on the weakness goggles by pressing T, and when they press it, the world will turn really red. This is like exaggerated. My actual game is less red than this, but it will turn red like this, and then the actual word you will see in the demo will turn. They'll be able to see the correct word that they need to draw. It's like an answer key, and you'll see in the demo. Next is the spell casting, which is the player is able to draw on 3D space. And I will go more into how that works later, but it involves the player drawing on an invisible plane in front of them. And then wherever their mouse kind of intersects with this invisible plane, it will draw a 3D point in space, allowing the player to draw in 3D. So, let's go into how the actual code is able to detect what the player is drawing and turn it into Japanese. So, Manga OCR, which is what I'm using, which I'll go into the next slide, but it's a vision encoder-decoder model. Basically, it's able to take in a PNG image, for example, and then it's able to that goes into the encoder. And the encoder encodes this data and sends it to the decoder, which is able to turn these blocks of the image into letters. And all you need to know is it takes in an image input, and then and outputs the resulting characters. In our case, it'll be Japanese. So I'm using the Manga OCR character recognition model, which uses the transformer encoder-decoder model. And as you can see on the right side, it's extremely accurate at taking in these images, which have these characters and text, and outputting the actual Japanese text. And it's free, and it uses Python. And it's extremely accurate for recognizing handwritten characters as well as text characters. And here's how the actual whole AI works. So in the actual game, which is on the front end, the player will draw on their screen, and they will draw on this invisible plane that's always in front of them, and it will store whatever they draw into a PNG. This PNG will then be sent to a local host Python server working in the back end, which has Manga OCR, the AI model, already preloaded on it. So the model will then take in the input, process it, and output the resulting Japanese characters that they drew, and they will send this information back into the game in the front end, where the enemy script will check, oh, did what the player draw match the correct character match the character of the attack I'm giving? If it does, then obviously the attack will break because the player successfully countered. If it doesn't, then the block will continue to hit the character, and you will see that in the demo. And as we can see, when we drew this and all, and this PNG got sent to the manga OCR, we can see it gave the correct output. And here it working. And when we draw it, the correct character there, you saw it break. I draw it here, it correctly breaks. And if you look at the actual debugging logged out here, you can see it's correctly outputting the character from the server. The server is correctly seeing what character the player drew. Alright, now we have the Anki menu, and with the Anki menu, I'll go more into the demo, but basically the player is able to adjust the space repetition algorithm based on how easy or hard they feel that it is. For example, if it feels like in general all the cards are too hard to remember, then you can adjust it. Alright, next I think is the coolest feature is the actual enemy. So the enemy is procedurally animated, which means its animations are calculated on the spot based on math and the terrain. So it looks like it's actually walking on the hills. When we go into a world with hills in the demo, you'll see that it's able to walk on the hills realistically. And once it gets close enough, it will start chasing and attacking the player. Alright. And here is a hiragana book. So the player is able to actually open this book, and then they'll be able to see all the hiragana that they're currently working on. And it's also, I need to mention that I actually only got the hiragana implemented for now, for this demo, but in the future I'll be quickly adding the kanji and then the other vocabulary, and then katakana as well. But for now, it's just hiragana. You can see all of it, the intervals and the days until due, and the pronunciations in this little book. I also added a health bar to the enemy, and the enemy will obviously take damage whenever the player successfully counters their attack. And finally, I added a ton of particle effects. I used this effects pack, and I adjusted it to work with my game a little bit better. And here's an actual image from my game. And then there's tons of particle effects for when the enemy spawns, does damage, attacks, and when the player attacks and deflects, and everything. Alright, welcome to my game demo for Kanji Katana. So if we open the hiragana book, we will be able to see all the words that we have due today. As you can see, it says days till due is 0, which means these are going to be the ones that we'll see today. And then these will be due tomorrow, and then the day after that, and then as you can see basically every single character we're going to learn, and this will automatically be updated as we keep on playing. And yeah, you can see everything that you're going to learn, and you are learning. Next, we can look at our memorize settings, which is basically adjusting the actual space repetition algorithm. And what this will do is, as we can see, we can adjust the easy interval and the hard interval, and I'll explain this increment days thing later. And the easy interval is basically just whenever you're fighting an enemy, it will keep on shooting blocks at you until it's dead, right? And these blocks that shoots at you will be random, and it will contain the words from this day. So, for example, if you have the word ka today, it will shoot at you over and over and over again eventually, randomly. Eventually, it will shoot at you over and over and over again. It could be 100 times. If you fail 100 times, then you're going to see it 100 times. But whenever you successfully counter the block twice, the card's due date will be updated, and it will be sent to be reviewed in the future. And what the easier interval does is it basically says that if the block is shot at you and you successfully countered it twice without ever failing, which means in total you only saw it twice, and both times you successfully countered it by writing the correct character, then it will be sent into the future a very long time. In fact, that time is calculated by 2 multiplied by the previous interval you had to wait before seeing the card again. The hard interval, on the other hand, is if you fail to counter it more than once or twice, then it will multiply whatever is the last interval you had this card for by 0.5. So if last time you saw this card was 10 days ago, and then you failed it multiple times, it would apply the hard interval before you, and then once you successfully got it, it would send it so you would see it 5 days in the future, which means you'll see it closer and closer. And this way, the harder cards you'll see very frequently, while the easy cards you'll see less and less, as it should be. So let's just load into our test world for now. This is our test world, and there is the enemy spawning, as you can see. And there he is. I'm already within his range. I see his health bar. If I see his health bar, that means he's already going to be chasing me. And you can see his legs are procedurally animated, although you'll see it a little bit better later. And as he comes towards me, you can see he shoots the character at me. And right now when the character hits you, it doesn't really do much, but yep, there it comes. I'm just going to be hit by it right now. And let's actually counter the next character. And when I press T, it opens the weakness goggles. And as you can see, when I open the weakness goggles, you can see the answer, which is, like I said earlier, this will have to be some kind of, there's obviously going to be some kind of penalty when you use this, but for now it's infinite. And you can see this is the character that I need to draw to actually break it. And let's actually do that for the next one. Right now I'm going to have the cheating mode on, but if I just draw the character in the air, like this, I press the button, if I do it correctly, it would break it. There we go. And I successfully broke it. Let's try this one. Like that. And there we go. Success. There's a little delay because the model takes a bit to kind of think. But you have to draw it pretty accurately. Let's try that. Hopefully that will work. There we go. And let's just draw a nonsense character. Like, this is the wrong character, right? And obviously when we do the thing, it's not going to work. And I'm just going to be hit by the character in that case. At the enemy. And as we see, all of these characters that we're working on right now is the ones that we're learning right now. And since the ooh, as you can see, I actually got it correct twice, it got sent back to 2 days. So we were doing this earlier, but I got it 2 times in a row, and now the actual due date is sent back into the future 2 days. And as you can see, it's turning to nighttime now, but and he's dead. And there we go. And then now we can see that we haven't finished all the characters yet, I think. As we can see, if we should still have some character, like for example this one is still due today, which means as long as it's still due, another enemy will appear. There we go. Load into the real world, world 1. So since we basically don't have that many cards left due, let's look at let's move a few days into the future. We still have 1 due right now, but let's move into the future. Let's say a lot of these cards have 2 days until due, and these ones, these ka, ki, ku, ke, ko, they will be due tomorrow. And just for the debugging purposes, we can actually skip to tomorrow. So now we're skipping to tomorrow. Now it's tomorrow. And if we look back at the hiragana book, we can see that all those that were 2 days now have turned to 1. And obviously the ka, ki, ku, ke, ko now says it's due today. And then our enemy, which we will find very soon, we see him spawning in the future, in the distance over there. I'm gonna go chase him down, and let's hopefully try and find a ka, ki, ku, ke, ko. And basically, based on how successfully you're able to counter his attacks, like I said, the intervals which you will see them will be adjusted. And whenever they need to review, they can just go to their hiragana book and they can see what they need to do. And then the days will automatically be updated. And yeah, that's basically my game for now. Thank you guys for watching. So, now that the demo's done, let's look at the limitations. So right now, Kanji Katana, as you can see, was for gamers mostly and for computer only because you need a mouse to play for now, and obviously most people are pretty bad when it comes to drawing with the mouse, which is why gamers who have more dexterity are probably better. But in the future, I hope to implement some kind of solutions to this. Right now, it's also only for English speakers. People who are learning English, people who can speak English fluently, can use this to learn Japanese. And then it's going to be released on Steam. So in the future, I want to add sound design, because right now there's no sound design. As you saw, it was completely silent. I also want to add more particle effects and animations, and definitely more enemies, because right now there's only 1 enemy, which is kind of lame. I want to add more types of word variety and types of attacks by the enemy. So for example, right now it's just you see the English character and you write the Japanese, but maybe there's one where you see the Japanese character and you write the English, and maybe there's one that plays the actual pronunciation and then you write the Japanese, for example. I'm also going to improve the spaced repetition algorithm, because right now it's very, very simple, with just the easy and the hard interval. And also I want it to support other languages, maybe. Who knows? And obviously it's going to be Steam published. Thank you guys for watching.